Hi everyone, how are you doing? I'm good, thank you.
Hey, Professor, I have a question.
Yes,
Hey, I was just wondering, when are you going to be posting this video for today?
it usually takes about an hour or two for YouTube to convert it over because when it comes from Zoom, um, it's because it's high definition and YouTube accepts compressed upload. So normally it's between like, in my experience, an hour or two. So hopefully I can get it up tonight. Normally, right after class, what I do is I download it and then I upload it to YouTube. So when the link is active, it would show on your page in Canvas.
Okay, thank you so much. Yeah, I'm going to be in class today, but I'm not able to see the screen right now because I'm driving to the airport. So I was just wondering,
Okay.
so I can, if I need any questions, I can follow the.
Yeah, so it should be up tonight. I try to wrap it up tonight and then I input attendance right after class. So
Okay,
you can check it out later, okay?
okay. I don't know if I'll be getting, because since I'm driving, I don't know if my phone's going to be kicking me out of the Zoom, but if I do, I'll try to join back as soon as I can, okay?
That's fine. Yeah, because when I pull the participation list, even when you get dropped off, it shows multiple instances under your name. Let's say like you to get drop off and rejoin, it show multiple instances.
Okay, then. All right, then. Thank you so much, Professor.
Yeah, you're welcome. Okay, everyone. Since we have about a minute left, if you can take a look at your lab from Canvas and download that so we can get ready. We are doing lab 9. And today we are going to work on Fibonacci and recursion. So let me get my REPL open here. And we have a few things that we need to address today. Fairly simple programs, nothing too major. Let me get my files open and I'll go into screen share. Okay. So in some courses, you probably heard of Fibonacci, but if you haven't, Fibonacci is a sequence that we would see represented in nature, right? Like as I mentioned in the last lecture briefly, that if when you look at a seashell or when you look at a sunflower, or even the daisy in our universe, you would see sequence that's represented biologically, or it could represent in design in different areas. And Fibonacci sequence would include recursion because the way that we would achieve the Fibonacci numbers is that we would start with either at 0 or seed at 1. And then you simply just take the previous 2 value to add it to equal to the next value. So I would seed this sequence at 0, and also the next value is 1. So A of 0 is 1 and A of 1 is 1. And so in this case, we would take 0 plus 1, we would get A2, that would give us 1, and then so forth. So we would take the 2 previous numbers, add them together to get the next value. And that's how you get from 0 plus 1 to 1, 1 plus 1 to 2, 1 plus 2 to 3, and so forth. And it can continue forever. Okay. So here on page 1, it shows you what the Fibonacci numbers would look like. On top of the page, I included some TED Talk information, a little bit about Fibonacci. So the pattern that we see is really represented in natural phenomena, right? In mathematics and science, we see that as well as we look at the sequence. We see this in art and nature. So today what we're going to be doing is we are going to take a look at how we would write it in C++ and to be able to derive a certain value in the sequence, and whatever the condition we say in the program. So here it talks about how the sequence is defined, and we would use recurrence relation, in which that a sequence, we can use multidimensional array, or we can even use variable to be able to achieve the next number that's going to be placed in the sequence by adding the previous two. And I want to bring your attention to how we would seed the sequence. So in the cases that we're using today, all the programs would seed at 0. But in the field, sometimes you would see programs that would seed at 1. So in such case, you would incorporate that either in the program, or you would work your algorithm to really represent a certain value at the nth position. So in all our programs that we're going to do for Fibonacci today, we are going to seed it at 0. Okay, so it starts at 0. So that means that we're going to have f0 is equal to 0. F of 1 is going to be equal to 1. And in order to get to f of 2, we simply take f of 0 plus f of 1 to get the next number, which is 1. And we would continue after that. Okay. And on the first page of your lab, it also talks about the mathematician that came up with this sequence. And it's Leonardo Pisa. And he's known for Fibonacci sequence. This was introduced into the European mathematics. And by history, what we see is that there had been discussion or description of a similar sequence or the same sequence in Indian mathematics. So, so people have studied this for a long time. And the reason why we're doing this today is I want to show you how you can implement recursive functions, and also to derive a certain value for Fibonacci sequence by implementing specific algorithm. And that's the whole point. Okay. So Fibonacci sometimes can be implemented in search technique. It can also be used for heap, and even graphs. So in some cases you would see it surface again, and in computer science we like to use it because it's really visibly easy to see. The calculation of this is easy to implement, so you can see the application behind it for different areas once you understand how it's created in as far as the programming. Okay. All right, so on the first page, it's generally just give you the details of what Fibonacci would be. So in the example 1, we are going to use recursion. And in the past few weeks, we talked about how we can implement recursion, how that would be beneficial, or it has drawbacks. So in example 1, this program is a very short program. It simply begins with the function header, it tells you that the function is to take integers and it's called fib. And we would pass int n into this function. And the criteria of this function is that it says if n is greater and equal to 1, return n. And we are, for the function itself, it's going to return fib. So it's calling itself, you see. So this is why we would say that it's calling itself continuously. That would be a recursive function. So it would return fib n minus 1, which is the previous value, the one right before the value that we're trying to determine, plus fib of n minus 2, which is the value before the n minus 1 or 2 places prior to the value that we're trying to find. And in the main, what we're doing is we would specify what our int n would be. So here is our n value. That would be the position in the sequence. We are looking for the value at the 11th position and in the Fibonacci sequence. And we would see out, so we would display that value. We're not displaying the entire sequence, but we're only going to display the value for the 11th position. And then we would return 0, which ends the program. So in the first program, it would look something like this. Okay. And you can simply run it after you write it in. And it tells me that the 11th value in that sequence is going to be 89. Okay. So with this, what we have is we would have it, the output for this program would be 89 is the 11th value in that sequence. Okay. Any question? So the things that you want to focus in is this section, right? That really represents the Fibonacci formula, where we would have the n minus 1 plus n minus 2 to represent the two previous value. And as the function calls itself, right? And here again, when we see out, we call that, then we would have the recursive function in this section. Okay. Do you have any question? Okay, so I wanted to begin with a very simple program. And in exercise, sorry if I mislabeled that on yours, but in exercise 1, what we want to do is we want to run the example program after we put it in our IDE or our text editor and then run it. You take a screen capture. Then for step A, we would verify to see if our program is output correctly. The reason why I have you manually calculate this is that I want you to examine to see if the output is correct. Not only that, if you're not familiar with Fibonacci, it introduces you to Fibonacci. Okay. So I start with f of 0 is 0. So I seed it at 0. And in the f of 1, I have 1. So these two has to be given in order for us to derive the next position, which is f of 2. Okay. So in Fibonacci, you have to start with these values. Now, in some cases, they would say, oh, well, we're going to seed it at 1. And then you would have to give the next value, which is 1. So 1 plus 1 is still going to give you 2 for the following position. But our end value is slightly changed. It's 1 less. So here we start with f of 0 is 0. F of 1 is 1. So we would take these, right? And then f of 2 is 1. Now, if you see it at 0 here, right, we would begin adding, right, after the first 2. So you would take 0 plus 1, which gives you 1. Okay? And for 3, we would repeat the process. So we would take f of 1, right? Sorry, I mistyped here. So we would have for f of 3, we would have f of 1 plus f of 2, which gives you 2. And then on the next one, f of 2 plus f of 3 to give you 3. Okay, so we would take this value, add it with this value to give us 2 here. And then on the next one, which is f of 4, we would add f of 2 with f of 3. So 1 plus 2 is going to give me 3. And so we would continue that. And the reason why, the program is going to give us the automation in that it's going to keep repeating it, right, as we continue to call it. And we wanted to specify that, yeah, we were going to go all the way to f of 11, which is the end value in the program. So that way it would produce the calculation and gives us 89. So as I continue to add the 2 prior values, I have f5 is 5, and then 3 plus 5 gives me 8 for the f6. 5 plus 8 gives me 13. 8 plus 13 gives me 21. 13 plus 21 gives me 34. 21 plus 34 is 55. 34 plus 55 is 89. Okay. So for the first exercise, for example 1, after we run the program, we want to calculate the value for f of 11. And you do see people post calculators for sequence like Fibonacci sequence, Lucas sequence, etc. online. But I want you to understand how that sequence is created, right? How do we calculate that? So here we verify that at F11, we do have 89. Okay. Any question as far as the first part of exercise 1 or example 1? Then for part B, after you have looked at your program, run your program, and calculate out your sequence, then you would explain how the equation of Fibonacci is integrated into the program to give you the output. So as I mentioned earlier, we want to pay attention to the function itself, how it's defined. So when we define this function, we're stating that if n is greater than or equal to 1, return n. And right here, we would state that it's going to return. So the equation itself is really here, but because how we want it to seed, we really wanted to state that inside the equation, inside the function in our program. Okay. So this is using a recursive function. It's gonna take the value, it's calling itself. So it calculates what n minus 1 would be. It's gonna add it to n minus 2, and it's gonna return it. and it's going to take the return value and plug it in as it display it at the end. And when we run this, we would see that it will be 89. Okay, so inside the main, we mainly call on it to do a display or show a see out, but we have to state what that end value would be. Okay, any question? So after you have explained, and you can put down a few sentences for that, right? Explain what each part really means inside that function and how it's used. For part C, I want you to edit the program, and I want you to use the 18th term we want to determine the 18th term for Fibonacci. So now as you play with this a little bit, 18 it's going to be able to produce. Okay. And it also did, as we discussed before with recursion, it really depends on, there's other factors we have to really consider. Our processor, our storage allocation, So when we put in the 18 term for the 18 as n here, it gives me this output. Now let's say I want to play with this and I wanted to go up to 88. Okay. Notice that I didn't get anything, and if it does produce something, it might take a while. Okay. So I think for the REPL, the limitation of this program would probably be about 70 something. So as you can see here, the drawback of this is that when you are trying to keep calling it for a later value in the sequence, if it can produce it, it would take a while, okay? Because it has to keep, because as it create the number in that sequence, it has to reuse that value and be able to produce it. Sometimes you would get an address, right? A memory address. So if you get like a series of numbers and letters, or 0 times, hexadecimal value, that means that it would put it in that location, but it's not able to return the value. Okay, it's not able to give you the output as values. It says that yes, I can put it here, some value, but I'm not able to do that. So the drawback with the recursion is that when we get later down the sequence, it probably is challenging to calculate if we write the function like, or if we write our program like this.
Does it depend on how strong your CPU is?
Also, it depends on your RAM and also your cache within your CPU. You don't have to have a very high-end CPU like that's fast, but if you have also internal storage to the CPU is important, because it's going to place all of this on stack and it's going to keep doing that. And it's, so a quick fix too is to think about how you would optimize space, like use variable or array to temporarily store some of the value as it's calculating it. So we have to consider a factor outside of the processor itself, but yes. Okay. Now we're connecting to an online compiler. Okay. So online compiler, that it's really also depends on how their architecture would be, and this is running Linux in the back REPL. Okay, question. Okay, so I showed you if you test it with a very large value, you see that it would either pause for a long time, or if it produced something, it might give you an address. We saw some of this earlier in the semester when we looked at one of the recursive program. But if you change it to 18, it can still produce that. Okay. If I change this to, let's say 38, it would still be able to do that. It will take a little bit longer, as you see. Okay, so we started to see that it start to lag. And you can double check too, because on some online compiler, it gives you a series of numbers. It doesn't necessarily mean that that's really the output. It's address, right? It's offset. So, oops. All right. So one is very simple. After you edit and put in 18 instead of 11, run the program, provide the screen capture. So I want you to see how, and you should play with it. So when I did this long ago, I had the student put in like 80, and you know, some of them were just like, oh, I don't know what happened. It stops working, or it's throwing in an error. So depending on the compiler. Okay. All right. Any question on one? Okay. So for number 2, we are going to use space optimization to determine the end value. So our output is still going to be similar to what we have. Our objective is to produce a value at the end position in that sequence. But the approach in example 2 is that we are going to allocate a space to hold specific value, so that way it can go back to that location to retrieve that value. Okay, so let me go back to my, I should just click back on here. But for number 2, it's also a fairly short program, not too long. Now, I left this on the top so you can see, right? Like, so if you see it like this STL is a catch-all STL. In the case where, you know, if you wanted to write a program real quick and you don't want to include like 5 different STL or 5 different file headers up here, then you can use include stdio.h. However, in Visual Studio, sometime, because if you don't have that with a certain package, it's going to throw an error. So you have to add in the file. I think I linked some videos a while back on the older labs on this. But anyway, so for us, we just need algorithm and IO stream, because we're just going to see out. So similar to example 1, you have a function. It's called fib. But inside this function now, you notice that we're using variables. Okay, so you have int a, it starts at 0. B, it starts at 1. And these represents the seeds, the beginning part of Fibonacci sequence. So, and then C is going to be our result, okay, when we add the values together. And then we would have the I to implement with the for loop for the index, okay. So here we would state that if n is 0, return a. It would return a 0. So at f of 0, we have 0, right? Then we would have a for loop. And when you look back in your notes, right, at the beginning, if you're looking at this or the calculation that you did for the previous one. So if I see it at these two, it doesn't really, the pattern doesn't really begin until f of 2, right? Like as we did the addition in the previous one. So with that, this is why the for loop begins at index 2. I is 2, and it's going to go up to the nth value, and we would specify that in the main. So in the for loop, what do we want it to repeat doing? The addition, of course, right, to generate the Fibonacci numbers. So we would say that C is equal to, right, C is A plus B, and A is equal to B, and B is equal to C, and return B. And we saw something like similar to this before when we were doing recursion with our search algorithm, right? And in the main, we would specify what the end value is, that you assigned it 9. So in this case, we're going to go up to 9. So it's going to loop up to that position, and we're going to see out. We're going to see out the value, which is here is where we call that function. Okay. So it should give you 34. Okay. Then in our next exercise, after we run the program, right, we take a screenshot of the output. We want to verify if the program gave us the right output for the nth value, which is 9. And I didn't retype, and you shouldn't have to, as we have all of this from question 1A already. So I just put down that f of 9 is f of 8 plus f of 7, or f of 7 plus f of 8. Then we would have 21 plus 13, which gives us 34. So it's verified. Now, based on what you see in the program, right, look at the function and explain to me how Fibonacci equation is integrated, right? Because it's really a step-by-step procedure on how it was incorporated, and that's the point that we want to make sure that we give you in these type of exercises, is to look at it and say, how did it really calculate this number? Okay. So in the function, as I mentioned before, where does it seed? How is the for loop implemented? What is that for? Right? And we need to take a look at how it's adding here and how it's able to store the result. Now, let's play with this and say that, hey, I wanted to maybe go to 89. Okay. So, or I wanted to go to 29. Okay. Now you can test it with a larger nth value to see if it's able to achieve that, right? And that's how we can see the capability of that program as well. Okay. So we started with, so because 9 is very easy, even if you manually add, you can quickly determine that. And with the computer, right, that's simple. Any question? Okay, so after you explain the component of the function, okay, and how the equation is seen or implemented in the program through the function. Then we want to edit it and we want to change it to the 14th term. And we wanted to see the result in that. So if I change this to 14 and run it, okay, it should give me 377. Okay. Now you can also modify it and have it print out, you know, each of the value from the sequence with using the for loop. But if we keep it like the original program, that would just going to give us the nth value. So as you can see, there's different approaches to Fibonacci. And if you can understand the very basic like this, right, you can write it in any language. You can say, oh, well, I can use a variable to handle it or create an array to store it, or I can just write a recursion program. Okay, so for part C, all you have to do is edit and make it 14, run it, show the result. Okay. And I want you to test it with different terms. So take it to its maximum capability, right? Use a higher number, like 4 for n, to see. If it start throwing you memory addresses, then, you know, is that adequate? Then for D, I want you to compare this program to the first example, example 2 to example 1, and tell me which one you think is better, right? Or because sometimes one would be better in one area and the other would not be, right? So I want you to compare the two, okay? In comparison with one, how are the variables used? What's the benefit of using the variables? And what's the benefit of the overall program functionality? Okay. And some of this come back to, you know, how the programmer is really preferred to solve that problem, right? You can solve the problem in many ways. And so we achieve the same objective by having two different approaches for 1 and 2. Okay, so test it with different values, provide a comparison for me. Okay, any question? Okay. So I want you to also see how these programs can be written in different ways. Okay. So after you complete number 2, we can proceed to number 3. I want to double check and make sure. Okay. Okay. Any question on 2 before we start 3? So in number 2, we use variables. In number 3, we are going to use an array. Here we have a function again, same name. Then what we want to do is we wanted to declare an array. Now, here it tells you that there's one extra to handle the base case, which is n is 0. So we wanted to have that f of 0 included for the seed. Okay. And we declare the int I. So for the seeds, the base, we wanted to specify it. So at index 0, it is 0. At index 1, it is 1. Okay, for the array. And then after that, we're going to use a for loop to fill in the value. Okay, so with the for, again, we're going to start at I is 2. Because remember, we're going to take 0 plus a 1 to get us to the f of 2 there. So we're going to start at 2, and it's going to go up to nth value. And in our for loop, what do we want it to repeat doing? Or how do, what kind of calculation is looping? So we have f of I is f of I minus 1 plus f of I minus 2. Take the 2 previous number and add it up, and then return it. Now, this is one way. You can do it other ways too, to really simplify it. And in the main, we assign 9 to n, so that way that would put a stop here. Okay, so it stops at 9. And then we would have it output in text. Okay. So again, we're going to get 34. So in this one, we're using an array, right? And unlike some of the traditional program that use array where you have to tell it how many elements, because the elements, the length of the array is going to be determined by n. And here we're using dynamic. So that way we just specify down here what that length would be, the number of elements that would go inside our array. Okay, and we wanted to have an extra one location for the 0. Okay, so this is using array. So after you put in example 3 in your IDE and run it, take a screen capture. Sorry. Then for example 3, then we want to verify if the result is correct by showing the calculation. So again, we did this in the prior one, and you can just include the same information. So f of 9 is equal to f of 8 plus f of 7, which is 34. And I want you to look at the program and explain to me how Fibonacci sequence is integrated. So we want to take a look at the function, how the loops is incorporated, right? And in this one, you want to mention that it's calculating each of the sequence value at f of 2 going forward, and it placed that inside the index of the array. And so explain how Fibonacci is integrated in the program. Then we can edit it, right? And it tells you to change it again to the 18th value. So all we have to do is modify this part. N is equal to 18 and run it. Okay. Then take a screen capture, and I want you to test it just like the last one with different terms and see how it's different, right? Is it better, worse than the other two? Okay. So let's say that we can test this. Let's say we wanted to make it 89. Okay. Or because I tested this earlier, so I'm using the same. What if you wanted to make it higher, 109? Okay. So there would be probably a ceiling somewhere, like it would reach a max capability. But on this one, as you can see, it's going to produce the later value quicker. Okay. Compared to even the example 2. And then of course 1 is it's gonna not be able to do anything for a while. If we go 80 or higher for N. Okay, so test it with different values and then provide a comparison for me. And all of these are very simple, they're linear, so you got like one for loop, and then the other one also have one for loop. So if you're looking at, just the process behind it, they're pretty close, but you have to think about how the storage is being used, or how location is being used inside the program, like variable or array, that would make a difference between one and the other. Our lab is pretty simple today. It's nothing too major. Any questions? Okay. No question, huh? All right, so after you test and provide the comparison, that will finish our example 3 program. Now in in the last part, I wanted to reiterate some of the information that we talked about on Tuesday, which is recurrence relation. And with recurrence relation, as you've seen in the first example program, you can use an equation that recursively define a sequence like Fibonacci using the previous term. And you might ask, well, what are those outside of Fibonacci? What other sequence can you use, right? So now you can also use this for multidimensional array values to be able to access those. But you have to have a base, like what we've been talking about. Okay. Now, all the later terms is going to be determined based on the result of the previous or the prior terms. And that's what recurrence relation really entails. So here is a list of recurrence relation. You got Fibonacci, which is what we see and use today. You got Lucas number. You notice Lucas and Fibonacci, same equation, but the base is different. So with Fibonacci, you start at 1, 1 or 0, 1. With Lucas, you start at 1, 3. You still add those together. So A of 3 after this is going to be 4 because you do 1 plus 3 is 4. And then 3 plus 4 is 7. 7 plus 4 is 11, and so forth. It's still adding the two prior values, but the bases are different. Okay. And then you got Padovan sequence, which is you would take f of n minus 2 plus f of n minus 3. So A1 is A2 is A3 is 1. So you do start at 1 at that point. So that's Padovan. And then you got Pell number. So these are the well-known sequences, especially if you talk to mathematician, right? So I wanted to add that so that way you know what they are. And we talked about recursive function in example 1, a function that calls itself. And it's the cycle for it would just include its own function calls. Now in recursive function, it's important that you include base cases. And you would include them in the other ones too, because if you don't, right, as you can see, Lucas and Fibonacci is the same as the equation, but the bases are different. So with the recursive function, if you use recursive function, you need to state the base case and you need to state the recursive steps. Okay. Which prior numbers are you operating on, right? And then it's going to continue to call itself. Okay. Now it tells you here, base case in recursive algorithm is the case that's no longer recursive, like in the case of factorial. So in the base case, we compute the result immediately after given the inputs of the function call. Okay. So now we would be able to generate the sequence by continue the recursive call, so more than one call using the same function, and that's the whole point. Okay. So in example 4, since we already did one on Fibonacci, what I wanted to include was a factorial program. And you've probably seen factorial program written a lot shorter than this, right? Because we have a lot of C out, but in this one, it's actually taking the user input. Okay. So let's go. Here. So I have a function called factorial, and that's the header down here. I defined it. Okay. And in the main, I have the main to ask the user to enter the number that we want to find the factorial for, record the input, and then see out. But we call on the factorial function right here. So in the function, we state our base case. If n is greater than 1, return n times n times factorial n minus 1. Because what factorial really is what we would take that value and multiply it by the one previous and the one previous and the one previous. And notice that we are it's a function that's calling itself there, right? Else return 1. So in the case where if I input, let's say that I wanted to go 6, right? So 6 times 5 times 4 times 3 times 2 times 1 is 720. But let's test the program. If I put in less than 1, it returns a 1. Because we wanted, because 0, right? Anything times a 0 is a 0. So we wanted to start at 1 and higher. So our base is going to be 1. Okay. And then we wanted to be able to multiply all the previous number with the value that we specify. Okay, so let's do 10. Okay, so this is a factorial program that uses recursion. Now in the last exercise, all you have to do is write and run the program, take a screen capture, and depending on your input, verify the nth value. So since I have used, like if you use a 6, you can say 6 times 5 times 4 times. Since I use a 10, right? So factorial of 10 is going to be equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, like that. Okay. And as we go, we would have n minus 1, n minus 1 from the previous one, n minus 1, n minus 1, and so forth. We would continue that. Okay. And again, we want to explain how the algorithm is integrated in the program, right? So take a look at the function itself, how it's defined. What is its base? How is it calculating? Is it calling itself? Okay. Then you're going to edit it and make it either, so you're going to do 2 try. One is going to be 15 and one is going to be 20. Okay, so I'm going to rerun this and I'm going to say, okay, well, I'm going to try 15 and then rerun again. I'm going to try 20. Why is it giving me negative there? Is that a valid number? Right? It's not. That's an address. Okay, so we're not able to produce factorial of 20 from this program in REPL. Okay, now you might be able to if you're using IDE at home. So on REPL, I'm not able to obtain the output. Okay. So for this program, I have to find a way to be able to improve it so that way I can produce output for larger value for n. Okay, and you can try to see where it caps at. So I think we did 15 earlier, so let's see if we can, sorry, let's do 17, right? It didn't take 17 either. Let's do 16. So roughly around there. Okay. And then what about thinking about type? Yes. That's what I'm getting to next. What about type? Your data type, right? Is integer adequate for these very large values? Thank you for mentioning that. Okay. Is it really, should we use double or something bigger? Okay. So if you modify the type, will that improve the program? Because it's really allocation for space, right? Okay, so test it, see the limitation, think about how you would improve it, explain the advantages and disadvantages of using recursive function, as you've seen this used in, you know, Fibonacci and also factorial. Okay. And it's pretty easy to write, right? Like it's simple. There's not a lot of things that goes into it. But I want you to think about how you can use it or optimize it. So, any question? Let's see. So our lab is pretty simple. We only had those to do. Don't forget that you have a quiz and a quiz review. You kind of mentioned earlier about the issue, so I fixed those questions. It's able to let me fix it live, so it shouldn't impact the rest of you. And the quiz is available, and the due date for this is the 26th. Also, the extra credit is due by the 26th. I will try to post the Zoom video after this. Okay. So I was playing with some of the module because I think I want to restructure the class a little bit. I think I wanted to go to chapter 16 after this, and then 17, and then come back to 5. I think there's some portion of the text, like chapter 14, it's just in, you know, there's only general information. There's not a lot of content in that. So I will likely do graphs. So chapter 16 next week. So I'll modify Canvas a little bit. So we're going to talk about graphs and vertices. So that way we can prepare for our project, understanding graphs. Coming back to some of the earlier things that we talked about from a week or two ago. Okay. And then we would either get to cryptography and relations. That will be at the end. Okay. And since next week is week 10, right? So if I feel like you grasp a lot of these things, what I'll do is I'll open the project and we can start thinking about how we want to approach the project. It gives you time to maybe, if you want to work in teams, you can look for people in class to work with. I can help you set up Microsoft Teams. So that way, you know, or use Zoom to do some part of it. Because I'm going to mainly lecture for about 3 more weeks, and then I'll give you time to do your project. So we won't have any lab after week 12. So I want you to use that time to be able to do your project. And in place of lecture, I will go over the final review. Okay. And so I will break it into portions. So if you want to, if you have questions, so the final exam entails everything we cover from the beginning until the end. So you will have all the questions similar to what you've seen on the quizzes. So now you're going into the final, you would have all your grades ready except for the exam and the final project, because it's due during the last week. Okay. So, and some of the components that will be required, but I'm going to use ePortfolio this time. So I will add that to the project so you can add your project on there. So you can share that with, potential employers when you interview, stuff like that. And if you wanted to link your GitHub on there, that's fine too. But I will also show you how you can use GitHub and post your project on there if you wish. I think that a lot of the students, they struggle with GitHub because they don't know how to use it correctly. So, but I have some questions in chat now. Like I mentioned, Daniel, possibly at the end of week 11, week 10 going into week 11. So after next week. Before I release it in week 12, and I felt like, that's not enough time for some of the students. And in the last 2 semester, I released about, week 11 or so, or the end of week 10. And it feels like they have enough time to do it. So, so that should give you about 6 weeks. And that's more than what most, what most professor would give you for a project like this. So you have to turn out a program, a C++ program that would meet the criteria that's applying discrete mathematics. And, it should have all the proper algorithm. There are certain things that I'm going to look for, and that will be part of the rubric. Okay, so we'll talk more when we go into the project, and then I'll touch on it every week on what you should be adding, tying back to the concept. Okay, coming back to the lab, do you have any questions for me before I stop recording? All right. So what I'm going to do is I'm going to stop recording. I'll stick around for questions.